Hello, now I discuss about traffic engineering. Now let's start. Traffic engineering. Traffic engineering is that phase of engineering which deals with planning and geometric design of streets, highways, abating lanes, and with traffic operation thereon as their use is related to the safe, convenient and economic transportation of persons and goods. Scope of traffic engineering. Several scopes are present in traffic engineering. Number one, traffic engineering may be divided into six major sections. Number one, traffic characteristics, traffic studies and analysis, traffic operation, control and regulation, planning and analysis, geometric design, administration and management. Now, the various factors which affect road user characteristics may broadly be classified under four heads. Four factors affect road user characteristics. Number one, physical. Number two, mental. Number three, psychological. And number four, environmental. Now, talk about static characteristics. Static characteristics of vehicle affecting road design are the dimension, weight, and maximum turning angle. Maximum turning angle which turn to be possible. The height of vehicles affects the clearance of the overhead structure. The height of driver's seat affects the visibility distance, and the height of headlight affects the headlight side distance at valley curves. Valley curves. Dynamic characteristics. Dynamic characteristics of vehicles affecting road design are normally three characteristics depends on dynamic characteristics. Number one is speed, acceleration, and braking characteristics, and some aspects of vehicle body design. Speed of vehicle. Speed of vehicles affects following factors are effects of speed and vehicles. Number one, side distance. Number two, super elevation, length of transition curve, and limiting radius on horizontal curve. Length of transition curves on vertical valley curves and on humps. Width of pavement and shoulders on straight and on horizontal curves. Design gradient, capacity of traffic volume, design and control measures on intersections. And now go through example. Before we start example, please subscribe this channel and click bell icon. If you click bell icon, you get update video when I upload it. And now start example in braking test. Example 1, in braking test, a vehicle traveling at a speed of 30 km per hour was stopped by applying brakes fully, and the skid marks were 5.8 meter in length. Determine the average skid resistance of the pavement surface. Here, speed 30 km per hour. First, we convert this speed in meter per second and divided by 3.6 and converted 8.33 meter per second. This speed is the initial speed. And now braking distance. Braking distance is specified L equal to 5.8 is a 5.8 meter length, and braking distance is equal to very common physics formula u square divided by 2gf. G is the gravitational acceleration, F is the skid resistance, and now skid resistance F equal to u square divided by 2gl. Just inputting this value and get the result, and this is the average skid resistance. Now example 2, a vehicle traveling at 40 km per hour was stopped within 1.8 seconds after the application of brakes. Determine the average skid resistance, and similar formula, similar procedure. At first We calculate initial speed in this section, and now braking time is given 1.8 second. Retardation, acceleration and retardation is vice versa, and acceleration u equal to u divided by t. U divided by t, this acceleration 6.17. From the retardation force, we know the force of Newton's second law of motion is equal to ma. A is the acceleration, m is the mass, m is the force, and now F equal to Wf, weight and skid resistance, equal to W A, F equal to W divided by G. Now vanish this W, and now F equal to A divided by G, and just input this value and get this skid resistance. And example 3, a vehicle was stopped in Example 3, a vehicle was stopped in 1.4 seconds by fully jamming the brakes, and the skid marks measured 7 meters. Determine the average skid. Similar formula, just input this formula and get the result. Average skid equal to A divided by G, and now A equal to 2S divided by T, and just input this value. S equal to 7 meter, which is given is the distance. G equal to 1.4 meter and G 9.8, and answer this question. And finally, example 4, a vehicle moving at a speed of 40 km per hour was stopped by applying the brake, and the length of the skid mark was 2 meter. If the average skid resistance of the pavement is known to be 0.70, determine the brake efficiency of the test vehicle. Now V equal to this value, and get this value, and N equal to this length, and F all are given, and now average skid resistance equal to V square divided by 2GL. Just input this formula in the value, and brake efficiency equal to 100 multiplied of average skid resistance divided by actual given skid resistance. And now get this value. These are the answer. Thanks for watching my video.